All right, polynomial boot camp day 2. Train hard or go, from home, huh? Get it? All right, day 2, multiplying polynomials. We're gonna multiply using the box. Maybe you've seen something like this before, but we're gonna use this idea. So this first one, I've got a monomial times a polynomial. So we have a single term times something with more than one term, which when we see these, I would imagine most of us think, let's just distribute. And if there's just a monomial outside, that's what I would do too. So, right, we could do negative 2n times 7n, which we would multiply the numbers to get negative 14. And then n times n is n times itself, so that is n squared. When we multiply, we actually just add the exponents. Right, this is n to the first. This is also n to the first, so that's n to the second. And then we would distribute the negative 2n times 1, which would just be minus 2n. These are not like terms, so we cannot combine them. We're done. But we can also use a box. And the box that I would use would only be 1 unit tall, because I'm going to put my monomial on one side. And then this binomial, I'm going to write along the top. And you could actually flip-flop where you put each one. But if I put 2 terms along the top, that means I need to have 2 columns. And then since I only put 1 term on the side, I need to have 1 row. And then we're multiplying, right? It's a multiplication problem. So if I multiply these together, I get negative 14n squared. If I multiply negative 2n times positive 1, that gives me minus 2n. And then once we have terms inside the box, we just combine like terms. There are no like terms though, so I'm going to put the one with the largest exponent first, and then the next term. Oh, so we can still use the box even while distributing. But to be perfectly honest, I wouldn't use the box. If it's just a single term, I would just distribute. All right, x squared times x squared is x to the 4th. But it's because we're adding the 2's, not because we're multiplying. Same thing here. We get 3 times negative 9 is negative 27. And then x squared times x to the 1st, it's not 2 times 1, it's 2 plus 1. So that's going to be x to the 3rd power. And then 3x squared times 5 is 15x squared. No like terms, so we are done. We could use the box, right? Again, if I use this, I'd have my monomial on one side, and then I have 3 terms, so I need to make this box pretty long, because I need to fit all 3 terms. Since I have 3 terms, I'll have 3 columns, right? And then 1 term just gives 1 row. And then if I do finish this off, this box will be 3x squared times x squared. Right, this box will be negative 9x. Make sure you include the sign. Negative 9x times positive 3x squared, which would be negative 27x cubed. And then the last one, 15x squared. All are different as far as like terms go, so we would just write them in order. 3x to the 4th times 27x to the 3rd plus 15x squared. Bonus question, see if you watched the last video. What degree polynomial is this? That's right, it is a 4th degree trinomial, right? But 4th degree because the largest exponent was 4. All right. The main thing we're going to be focusing on though is multiplying binomials together. And there are ways that you can distribute this by double distributing or something that is called the FOIL method. But the way we're going to teach it in class is using the box. And part of the reason we want you to use the box is it's going to help us do something we call factoring later on in the course. And so if we can learn how to use the box, factoring just becomes reversing the box, which is a nice visual way to do that. So I have 2 terms and 2 terms. So my box needs to have 2 rows and 2 columns. And then my first binomial, I can either put it on the top or on the side, doesn't matter. I usually put my first one on the side, and then the second binomial, we'll color code it here a little bit. This one here I'm going to put on top. And then to figure out what goes inside the box, we're just going to multiply. So to get this first box, I'm going to do 4x times 1x, which gives me 4x squared. This next box will be 4x times positive 2, which gives me 8x. This box will be the 3 times x. And then finally, this last box will be 3 times 2, so positive 6. Once we get all of the terms inside the box, we now need to combine like terms. And this time we do have like terms. So when I combine like terms, I always start with my largest exponent, right, 4x squared. That one did not have any like terms. But what can I combine the 8x with? Right, I can combine it with 3x because they both have x. So I can take these like terms and add them together. 8x plus 3x is 11x. And then finally we have 6 all by itself. So we end up getting the trinomial 4x squared plus 11x plus 6. All right, let's go ahead and set this one up here. It's going to be a 2 by 2 because both of these have 2 terms. When I put my minus 2, I personally like to put the minus right next to the 2 so I don't forget to make that a negative 2 when I multiply. And then my second binomial is x minus 3. And so then I'm going to start filling in my boxes. This box will be x times x, which when we multiply, when you multiply something by itself, that means you're squaring it, right? So this is x squared. X times negative 3, negative 3x. Negative 2 times x is negative 2x. And then negative 2 times negative 3 gives me a positive 6. And then hopefully you notice we have these like terms right here. So when we go to combine all of these, x squared goes first. We can combine negative 3x and negative 2x to get negative 5x. And then finally we have plus 6 at the end. So we get the second degree trinomial x squared minus 5x plus 6. Okay, 2 more examples. Right, 2 terms, 2 terms. So I'm going to have 2 rows, 2 columns. 3x plus 2, 3x minus 2. And just a little check-in. What's going to go in my first box? That's right, 3x times 3x is 9x squared. And then this box will be negative 2 times positive 3x, which makes negative 6x. And then we have 3x times positive 2, positive 6x. And then 2 times negative 2 is negative 4. Okay, this one when I go to do my like terms, what's going to happen when I combine my x's? They're gone, right? Negative 6x plus positive 6x is 0x. I don't need to put 0x right here. They're just not there. But we do still have minus 4, so that will go at the end. Okay, one more example. All right, hopefully you're getting the hang of this. We've got 2 terms by 2 terms, so we're going to have a 2 by 2. Right? 2 columns, 2 rows. X minus 4. 3x plus 2. First box is going to be our first terms multiplied together. This one will be x times 2. Then we do negative 4 times positive 3x. And finally, negative 4 times positive 2. And then we combine like terms, which you're starting to notice that typically we get like terms on the diagonals. It won't always happen, but a good chunk of the time. 3x squared goes first because it has the largest exponent. Combine these like terms to get negative 10x. And then our constant goes last. All right, let's see how you're doing. Go ahead and multiply this problem together. All right, well, let's go ahead and see how you did. All right, got my box. 3x plus 2 can either go on top or on the side, doesn't matter. 5x minus 4 will go in the other spot. And then I can multiply to get 15x squared, negative 12x, positive 10x, and negative 8. Finally, take all those out and combine like terms. We've got like terms that add to a negative 2x, and then our constant of negative 8. So hopefully you got 15x squared minus 2x minus 8. Not too bad. Okay, this one always messes people up, so I throw it in here just to make sure we don't make this common mistake. Because a lot of people will see, oh, this is squared, and they'll just do 3x squared plus 4 squared. And they'll put that. They'll do 3x squared plus 16 and call it good. But we know better than that. Because what does it mean to square something? Right? To square something means we're going to multiply it by itself. So I'm going to rewrite this as 3x plus 4 times itself. 3x plus 4. And so now we're back to a problem like we've been doing where we have a binomial times a binomial. So I'm going to put it in the box. I'm going to put one of the 3x plus 4s on the side and the other 3x plus 4 along the top. And when we multiply, we do get 9x squared. And we do get 16 in this last box, right? So it's similar to this. But if we didn't write it out, we might forget to do 3x times 4, which will give us 12x. And then this other 3x times 4, which gives us 12 more x. And we end up with 9x squared plus 24x. We almost left that out. Plus 16. So be very careful. Anytime you see that you have a binomial squared, write it out twice. Once you write it out twice, that will be your reminder to put it in the box, right? So x minus 8 squared is going to be x minus 8 times x minus 8. Oh yeah, I can put that in the box. All right, so I'm going to put one of the x minus 8s along the side, the other x minus 8 along the top. And when I multiply to fill in the box, I get x squared. X times negative 8 is negative 8x. X times negative 8 is another negative 8x. And then our last box, negative times negative is a positive 64. So when we take these out, we get x squared minus 16x plus 64. All right. Time for you to try another one. Let's make sure you were paying attention right there. What is 2x minus 5 squared once we simplify it? All right, hopefully you remember to write it out twice. And then put each of those around the box. 2x minus 5, 2x minus 5. And when we multiply to get each portion of the box, we get 4x squared minus 10x, and this last box, what goes here? Negative times negative is a positive 25. And when we pull all of this out, we get 4x squared. Both of those are negative, so that's just a bigger negative, right? Minus 20x, and then plus 25. All right, if you've got this down, you've got the basics, which means we can go ahead and try one of these bigger problems, right? We could do any polynomial times any polynomial. Just the more terms there are, the bigger the box. So this one we have a binomial times a trinomial. So I'm going to go ahead and put my binomial along this side. If you wanted to put the trinomial here, that's fine too. But then if I put my binomial there, I need to put my trinomial along the top. And so my box, instead of being a 2 by 2, is now going to be a 2, right, 2 rows, by 3 columns. That just means we have more terms to multiply, and in the end we might have some more like terms to combine. But it's still the same thing. X times 2x squared, right, this is really x to the first. So that gives me 2x to the third power. Right? If we have 1 here and 2 here, that's a total of 3. So we add the exponents. 1x times 3x is 3x squared. X times -1 is minus x. 2x squared times 4 is 8x squared. 3x times 4 is 12x. And then our final box is going to be 4 times -1. So we got all of our terms. Now we just need to combine like terms. We start with our largest exponent, which does not have a like term. I just put it down here by itself. But we do have like terms with the x squareds. So how many x squareds is that? Right? It's not 24. We're not going to multiply anymore. We already multiplied. When we add those together, we get 11x squared. And then we have 12x and -1x. 12 minus 1 is 11. And then we have our constant at the end, minus 4. So this ends up being a third degree polynomial with 4 terms. And that is it. All right, I'm going to skip this one because I want to go and see if you can do this checkpoint. I think you got this. Let's see how you do. All right, so we had x plus 4 along one of the sides. And then x squared plus 3x minus 2. So this is a 2 by 3 box. All right, and the box keeps everything nice and organized, which is another thing I like about the box. But x times x squared, that was x to the third. X times 3x is 3x squared. X times -2 is -2x. And 4 times x squared is 4x squared. 4 times 3x is 12x. And 4 times -2 is -8. So in the end, we've got 1x to the third. We've got like terms right here, which gives me 7 to the third. There we go. 7x squared. We can combine those as well to get plus 10x. And then we have minus 8 at the end. All right. Now for everyone's favorite problem. The one where there's no more problems left. See you later.